What we are actually intersecting, and if you take a look at this guy is y equal x, or 3 over x. That's a rational function. 1 over x, vertical stretch factor of 3. This is a circle. Go to x squared plus y squared equal 10. We saw circles back in chapter F. He's centered at 0, 0, and a radius of square root of 10, which would be 3 point something, because 9 is 3 squared. So that says I've got a circle, and I have something like this going on. No, that's stupid of me. We have a circle centered at 0, 0, and then we have something like this. So that says I'm probably looking at probably 4 answers, 4 places of intersection. And it takes a lot of experience to look at something and say this is exactly what I think is going to happen. So if I solved for y, and then I take this y and put it in for that, that says I'd have x squared plus y squared equals 10. Y is 3 over x. So that x squared plus 9 over x squared equals 10. And now I have a rational equation. And how do we solve a rational equation? A rational one, not a polynomial, but a rational. What's the first thing you always have to do? No. What's the first thing you always have to do with a rational equation? Clear the fraction. So multiply through both sides by x squared. So this gives you x squared times x squared plus x squared times 9 over x squared equals 10x squared. X squareds reduce out, so you get x to the 4th plus 9 equals 10x squared. Now it's a polynomial, so you bring everything to the same side, 0 on the other, so x to the 4th minus 10x squared plus 9 equals 0. Now some of you could factor it as it stands. X squared is the center term, so it's going to be an x squared minus something, x squared minus something is what it amounts to. Or if you remember, back in the ancient times, we did this by substitution. Right, so u is equal to x squared, and then u squared is x to the 4th. This becomes u squared minus 10u plus 9 equals 0. It's not necessarily the way I would do it, but a way that reminds us of a method that we have to solve certain types of equations. We can use substitution. And then this factors into u and u, 9 and 1, minus and minus, so that u is 9, u is 1. But we know u is x squared, so x squared equals 9, x squared equals 1. And now we can use the square root property on it. So square root of both sides. Don't forget the plus or minus, so that x is plus or minus 3. Square root of both sides. Don't forget the plus or minus, so that x is plus or minus 1. Now that gives me the fact that I have 4 intersection points. Those are the x values of those 4 intersection points. If I were in calculus, it might be very likely that's the only thing I might be interested in, are the x values. Because that gives me essentially the x's that the graph is traveling between. So it gives me boundaries, which is what normally happens. It gives me boundaries that I can work with. But this is algebra, so we have a whole different world in algebra. So now we need to find the y values. And I know that I have y being equal to 3 over x, so that if x equals 3, then y equals 3 over 3, which is 1. So one of my answers is 3, 1. If x equals minus 3, then y equals minus 3 over 3, which is minus 1. So another answer is going to be minus 3, minus 1. If x equals 1, then y equals 3 over 1, which is 3. So it's 1, 3. And if x equals negative 1, then y equals 3 over negative 1, which is minus 3. So it's minus 1, minus 3. A little bit big. So we've ended up with 4 answers, which is 3, 1, negative 3, negative 1, 1, 3, and negative 1, negative 3. And like I said, what we're dealing with is a circle and this guy. So there's 1, 2, 3, 4 coordinates. 4 points of intersection, which should make sense.